first glance, students will see fractional compound angles like 15 theta by 2 alongside large multiple angles like 8 theta and completely lose their minds thinking they need to use complex half-angle expansions or calculate giant values. The sharp move here is a masterclass in identity bundling. The massive trigo expression collapses beautifully into a standard compound angle identity before you even touch the value of theta.
Hey thinkers, welcome back to Think Sharp Alley, where every turn leads to a smart solution.
Let's open up the bracket to see the underlying pattern. Now let's group the terms to match our classic identities. Look at those two brackets. They are a perfect match for standard trigonometric expansions. First bracket fits cos A minus B, which is equal to cos A cos B plus sin A sin B. And second bracket fits sin A minus B, which is sin A cos B minus cos A sin B, where A is equal to 15 theta by 2 and B is equal to 8 theta. Now let's compute the common angle A minus B, which is 15 theta by 2 minus 8 theta. Upon taking LCM, we get 15 theta minus 16 theta. That gives me minus theta by 2. Substituting this back, the entire monstrous expression completely collapses into cos minus theta by 2 plus sin minus theta by 2. Now we know cos of minus x is equal to cos x and sin of minus x is equal to minus sin x. So our final simplified expression is cos theta by 2 minus sin theta by 2. Let's put this aside. Now we bring in the given data, cot theta, which is equal to minus 1 by 2 root 2 and pi by 2 less theta less pi, which means theta is in the second quadrant. Now we need the half angle values. So let's find cos theta first. We know cot theta is equal to base by perpendicular, which means if I take base to be 1 and perpendicular to be 2 root 2, we can find out hypotenuse by Pythagoras theorem, which says h is equal to root over p square plus b square. And from here we get 2 root 2 whole square, which means 8 plus 1 square, which is 1. That's root 9, which is equal to 3. Now cos theta, since theta is in the second quadrant, so cos will be negative. So we will have negative base by hypotenuse. So base is 1, hypotenuse is 3. So cos theta becomes minus 1 by 3. Now let's apply the half angle formulas. Sin cos square theta by 2, which is equal to 1 plus cos theta by 2, and sin square theta by 2, which is 1 minus cos theta by 2. So putting the values, we get this, and finally 1 by 3. Similarly, sin square theta by 2 gives us 2 by 3. So let's keep these values. Next step is a crucial quadrant check. Since theta lies between pi by 2 and pi, dividing by 2 gives pi by 4 less theta by 2 less pi by 2, which means theta by 2 is between 45 degree and 90 degree, which means theta by 2 is in the first quadrant. So both sine and cosine values must be strictly positive. So cos theta by 2 is root over 1 by root 3 and sin theta by 2 is equal to root 2 by root 3. Now the last step, final substitution. Let's substitute this into our simplified expression, that is cos theta by 2 minus sin theta by 2. So we get 1 by root 3 minus root 2 by root 3, and that is equal to 1 minus root 2 by root 3. So if we see our question, the solution perfectly matches with option number D. Bundling terms first will save you minutes of scratchpad work on exam day. If you spotted the compound angle structure immediately, drop a thunder in the comments, hit subscribe to Think Sharp Alley, and let's move to the next question. See you!